I'm Dr. Kelly Hoover, and I work on radio frequency. Radio frequency is a form of dielectric heating. So what is dielectric heating? Dielectric heating uses electromagnetic waves, which are microwave or radio frequency waves, to create heat to rapidly sanitize shipping pallet or wood packaging materials. Electromagnetic energy produced by dielectric heating converts into heat when it interacts with moisture, just like at the ordinary kitchen microwave oven. Just as the home oven takes longer to cook food, requires preheating, and heats the entire chamber compared to your kitchen microwave, dielectric heating heats faster than a conventional kiln oven. Microwave and radio frequency do not require preheating, and most of the energy is absorbed by the product being heated rather than having to rely on conductive thermal heat transfer from the surface to the core of the product, so it heats much more quickly. Dielectric heating converts about 80% of the energy into heat, in comparison to 10% efficiency with conventional ovens. Radio frequency and microwave are two forms of dielectric heating that differ in wavelength, but heat in a similar manner. Radio frequency has been used by companies for years to dry wood and wood substrates with adhesive bonding applications and food processing. The Commission on Phytosanitary Measures of the International Plant Protection Convention, which sets the treatment standards for commodities that are exported from one country to another, approved dielectric heating as an effective treatment for wood packaging material under ISPM 15 for both microwave and radio frequency. Given the greater wavelength penetration with radio frequency than microwave, radio frequency can effectively treat or kill invasive pests in larger wood sections such as dunnage. Dielectric heating occurs through dipole rotation and ionic conduction. A dipole is a molecule like water in which a concentration of positive electric charge is separated from a concentration of negative charge. Back to Physics 101. Opposite charges will attract each other. Ever hear the phrase opposites attract? In contrast, like charges repel each other. That is, a positively charged object will exert a repulsive force upon a second positively charged object. This repulsive force will push the two objects apart. For radio frequency, dipole rotation occurs when the treated material contains polar molecules, water, where one end of the molecule is positively charged and the other is negatively charged. Polar molecules will align in the electric field produced by electrically charged plates. These plates produce an electric field that alternates between positive and negative charges millions of times per second. So 1 megahertz equals 1 million times per second, causing polar molecules to constantly rotate to align with the opposite charge produced by the plates, creating friction that rapidly generates internalized heat. So charged particles in the material are constantly moving to the opposite charged plate, adding further friction. These processes generate kinetic energy in the form of heat that is referred to as volumetric heating, because it heats the entire volume of the product all at once, not just the surface. The same thing happens in your home microwave, but the depth of penetration is less than for radio frequency. Wood contains moisture throughout its structure, so dielectric heating simultaneously heats across the whole profile of the wood. In contrast to dielectric heating, conventional heating only heats the surface of the product, relying on thermal conduction to heat the interior of the product, making it a slower process. With RF heating in particular, the surface of the wood is cooler than the core because the outer surface radiates heated moisture into the surrounding environment. It's similar to the purpose of sweating, to cool our body down when we're overheated. Because of this, the temperature at the surface is cooler than the interior of the material being heated, which allows the operator to monitor temperature from the surface without having to monitor the core temperature. RF heating is typically used at commercial ranges from a few megahertz up to 50 megahertz, which provides greater wavelength depth of penetration. Microwave also heats volumetrically by interacting with water molecules in the treated materials, but the frequency of the waves is much higher than for RF, so depth of penetration of the waves is less, typically 9.15 megahertz or 2.45 gigahertz for most commercial applications. For example, heating rates of insects and grains using RF were shown to be 3 times faster than heating of the surrounding grain material. In materials like wood, the component with the highest loss factor absorbs the biggest part of the energy. So any pests inside the wood materials that contain water begin heating immediately and reach lethal temperature about 40 times faster than conventional heating.